Hello, my name is Indiana Renfro. Welcome to PHYS 2212, Lab 2, Line of Charge. And in this lab presentation, we'll go over the introduction, a review over Lab 1, computational data, and conclusion. The purpose of this lab is to continue the work done in Lab 1 by instead of finding and creating a point charge, we create a line charge model. This will give us a more accurate calculation of Q. This lab is all computational, and since all the experiment itself was conducted in the previous lab, so at the coming results, the magnitude of the electric force is 5.67 10 to the negative 2 plus and then there's the magnitude of the gravitational force, which is 0.119 newtons. Important concepts, there are 4 observed in this lab: Coulomb's law, the electric field, the gravitational force, and superposition principles. The following equations are applied to each. Some assumptions in this experiment we have is the U-tape can be divided into multiple equally charged segments. Each segment is considered a point charge. The sum of all the charged segments would be the total charge, and we will ignore air resistance. As a review from Lab 1, our initial conditions were the length of tape 0.20 meters, the width of tape 0.02 meters. The mass of the tape was 1.21 times 10 to the negative 3 kilograms. The distance between tape A and B was 0.005 meters. The system was tape B, and the surroundings for tape A. And we used the same assumptions as I just mentioned. And the findings were the magnitude of the electric force was 3.8 times 10 to the negative 6 newtons. The magnitude of the gravitational force was 1.6 times 10 to the negative 2 newtons. And the charge for the tape we found there was 5.7 times 10 to the negative 9 coulombs. And the electron efficiency was 2.31 times 10 to the negative 19 electrons. Here's the computational model. This is where all of the lab happened. We have our physical constants we use, our distance, length, gravitational constants, and Coulomb's constant. We then applied the mass of the tape and the charge of the tape from Lab 1. And then we edited a function to create the electric field by using E field and then Q equals charged particle. Then we found distance, and then we find the magnitude of distance and the direction of distance. And then we plugged it in to find the electric field of the tape. We then created a function to create a line of charge. We didn't edit anything here. This was given to us. And then we created lines of codes for the tape themselves at the top tape, and we added their position vectors of their distance and length, and then the bottom tape as well. Computation model continued. We had the electric scale here. And what is happening here is each tape is simulated as a line of point charges. The top tape is the system, and the bottom tape is part of surroundings. At the location each DQ in the top tape, there's an electric field produced by the collection of charges that make up the bottom tape. And these will create N arrows for these electric fields, placing their tails at each DQ in the top base. And here's the following code that's doing that. So we'll calculate the electric force of the top tape due to the bottom tape. And by adding the forces of each DQ in the bottom tape, we might interact with each DQ in the top tape. So here's that code. And then finally, we found the net electric force and gravitational force with the following code from what we found in calculating the electric field from the top and bottom tapes. And these were the results. The magnitude of the electric force was 0.0567447, and the magnitude of the gravitational force was 0.118. So possible sources of error could have been the code ran too fast. It's kind of hard to find errors with the code. What if we had modeled each of our tapes as a single point charge like in the previous lab? Well, in the previous lab, we found the point charge model, the charge was 5.74 times 10 to the negative 9 coulombs, and then the line charge model 2.18 times 10 to the negative 14 coulombs. And why do these estimates differ? Which value is most likely to be closer to the real value than why? The estimates simply differ mainly because they use different models to find the charge of the tapes. And the line charge would be the one most likely closer to the real value, mainly because it provides a more realistic approach to the charge value.